So let's look at the bad tests. What they are like? They are like unrepeatable tests, mainly because it's erratic tests, because it has dependencies on external systems, right? Like it has dependencies on system services like clocks, date, time. If you have time-specific things, it's really unrepeatable. If something is to go out every midnight, it's based on time, dependency on time. It's unrepeatable, right? So how would you break the dependency if you can only run the test only at midnight, for instance? Like you need to break the dependency. You need to use a virtual clock and fool the system to be thinking, okay, it's running at midnight at this instant, right? You need a virtual clock, virtual date, so you can, it's kind of like a time travel kind of a thing. In Ruby, you have a time cop gem that allows you to reset the time to whatever time you want, okay? So that your test becomes repeatable. It's not dependent on those kind of things. So the interacting test, if one test fails, leaves the system in a certain state, and the other test depends on the previous test passing so that it can continue and work. So you have a test interacting with each other because the test context is being shared across the test. And ideally, if you see in the teardown phase, we want to revert back release all the resources so that there is no interaction between tests. Okay, they are isolated. Slow tests for many reasons, right? If you have a data set that is too large, then it's really necessary to specify the behavior. You're creating too many objects for the test fixture. Then you need to create the minimal amount of test fixture, minimal amount of objects created to test your system. Otherwise, unnecessarily you're creating all these objects, which is going to slow down your system, right? And also, you need to avoid going over the network and actually hitting external systems as much as possible, so you can speed up your tests. Isolate your tests from all those external things, so you can speed up your tests, so you can run quickly, right? You want quicker feedback. Integration tests obviously are going to be slow. There's not much you can do. You have to make sure you can actually integrate with them, but you will run them less often. Not once a night, like overnight, it's going to run and it send you the report, which one passed and which one failed, right? But local tests I am running as a developer, I want them to be really fast. And this assertion role is basically, sometimes assertion 1 fails, sometimes assertion 2 fails. You have like 4 or 5 different assertions on something, and you don't even know which assertion is going to fail for what reason, because you have all these dependencies on different things. So you always want to have just one assertion fail, so that it fails for one reason only, so that you can go and isolate, okay, pinpoint, this failed because of this particular reason, and you can actually go and fix that thing in your code. Frequent debugging, right? Frequent debugging is, even if you have a test, if you want to frequently debug, there is something wrong there. We are writing the test to prevent this frequent debugging issue. We don't want to spend our days in the debugger trying to find the bug. We want to localize the defect, and we want to find and fix the problem quickly, right? Manual intervention, again, unless you do something manually, you change the configuration or something, the test will not pass. Again, it requires some kind of help from the developer or something in order to do this. Again, it happens because of the dependency, okay? If you have to manually intervene, there's something is wrong, because it cannot be automated, it cannot be just run by itself. It's not self-checking, basically. Conditional test logic, we already saw that. You need to avoid that. These are bad tests. Complex tests, which is like 15, 20 lines of code, it verifies this, that, and all, everything but the kitchen sink kind of a thing, instead of just testing one thing and one thing only and being simple. Okay, the complex tests can happen because of the eager tests. Like I said, it can be verifying like 5-10 different things, which are irrelevant, different concerns, all these things. General fixture. You're using general fixture, which means you want to reuse the setup code. So you have a general fixture, you have a before each block, but the objects you create a lot of objects there, a huge graph of objects, but not all the tests require them. Some of them only require few of those objects. So you're unnecessarily using general fixture so that after each test runs, even the objects that you don't need are actually being created. So that will also create a complex test, as well as it will be slower, and the intention of the test will also be kind of not clear why you're actually having it. Irrelevant information, actually things that are not related to each other. Sometimes you are like testing the business logic through the UI layer. If you're going to test the business logic, you might as well have the unit test the domain model. You don't want to go through a UI layer, because the UI is bound to change a lot. So, that's what's happening in the controller test. You're testing the controller, you're testing the UI. If the UI, in the initial stages, UI will change a lot. UI is going to change, the structure of the HTML is going to change, a lot of things is going to change, the way it's going to be displayed are going to change. If it change all these irrelevant details, will create complex tests. Hard-coded test data. Again, hard-coded test data, data duplication. -1 for, illegal primary key, for instance. To signify you don't really know why it is there. Indirect testing is like you're testing the business logic to the view layer, for instance. Going through several layers to test the particular layer. So the changes of one layer will impact the other. Long setup code. You want to always minimize the setup code. You want to be really concise and clear when you're doing a setup code. Create minimum number of objects you need. Otherwise, you end up with the really confusing setup code. Setup duplication. There is actually a force that there's interplay between the setup duplication. You want to minimize the duplication. At the same time, you want to also minimize this long setup code. You want to share as much as possible across all the tests. At the same time, you want to minimize the amount of objects you want to create, right? You can, if you create more objects, you can share across more number of tests, right? Because it's more generic. But it's also going to create instances where certain objects are not really required, right? So one way to deal with this thing is to have a context. That's why you have a nested context. You just say, okay, for this scenario, for this context, you can have this setup that I can share across all these tests for this particular nested context. Fragile tests just break, for lots of reasons. Tests can fail because of all these 4 different reasons. How do I categorize according to these 4 reasons? There is something called as root cause analysis. 5 whys. You keep asking yourself why. Why do we have a fragile test? When you encounter a fragile test in your project, if you keep asking yourself the why 5 times, that root cause can be categorized into these 4 broad categories. Either it is the interface sensitivity, like the UI layer, like I was talking about. UI changes a lot. UI is the thing which changes frequently, and marketing comes up with a new thing and it changes a lot, and suddenly everything that you're testing on, if it's view tests, all the view tests are very tightly coupled, it's going to break. Okay. And then the behavior sensitivity. The behavior is the customer comes up with a new requirement, and the marketing comes with a new requirement, and they give you the new requirement. And if you just code the new requirement, the tests are going to break, right? Because the tests are written for the old requirements, right? If the behavior changes, test should actually fail, so that because its code is broken as far as the test is concerned. So the test is the one which is going to actually drive the code change, so that the new behavior comes in. The test actually can detect conflicting requirements, right? If you are adding in a new feature, if it's just going to conflict with the existing one, your old test will fail, right? So you want that, being able to identify the conflicting requirements, vague requirements, as language changes.
Just to be clear in that case, are you recommending if requirements do change, you write a test for the new requirement and then go back and fix the old tests?
It's up to the customer to decide what is valid. This is how our existing system behaves. Are we changing the existing way things behave? Is this going to be overriding us, or do you want to preserve the old one? Because we have a conflicting requirements. Conflicting requirements, sometimes it comes through. Vague requirements, all this thing comes through. When you want to actually make it work, that's when we have this problem. And you have to resolve it. They have to resolve it. It's not up to me to decide what the customer is going to get in the next release, right?
So I'm saying, do you recommend writing a completely new test for the requirement, or finding the old test and modifying it, or does it really not matter?
See, when you're going to do test-first programming, when the new requirement comes in, I'm going to write a test.
Okay. A new test, not necessarily
acceptance test, right? To prove that it doesn't exist yet. It's a new behavior. I write this test, and then I start using that to write the unit test, right?
Okay.
And if when I'm trying to make the new unit test fails, okay, because it's not there. When the new unit test passes, the old unit test is going to break. Why? Because of the conflict, right?
Oh, so always write a new test.
Always start with the test first.
What I have been doing, like modify the old one. That's bad.
The problem, okay, if you don't do test first programming, you will not reap the benefits of test first programming. Benefits of test first programming are minimalistic code, minimalistic design, simplicity. That's what we are aiming for. No waste, actually. There is no waste. You don't speculate what the customer needs or what you need. It's all driven by the acceptance criteria that we have agreed with the customer.
Copy paste the old code.
If you copy,
Modify the paste then.
yeah, because these things happen. This is like it happens, and how will you deal with it? This is how we deal with it.
Because we know, like we have written this code to test this, right? So we just either delete that or copy paste.
Yeah, if you just want to go home, yeah, that's what you have to do sometimes. But the thing is, like, if you want to, it's a way to communicate. It's up to them to actually decide which one is a higher priority for them. Satisfying a new customer who is requesting this, which is completing with the old customer, who is paying them more money. Only they know, right? We don't know that. We cannot make the decision, right? It's up to them to tell us which provides them more business value, right?
Another question. You said, let's say if you have a before each, and then you're creating an object and assigning some attributes. Let's say some of the tests are not using that, like doesn't require that object to be initiated. Set
a different context. That's what I was saying.
Yes, set a different context.
Different context. That's why you have nested context in aspect, right?
Yeah.
You always want to minimize the amount of objects you need. Right?
Yeah. So within a context, just do before each, and then.
Yes. Okay. So user is valid, you do this. User is invalid, you do that. But it depends on. You always want to minimize the context so that your tests are running faster. And also it becomes clear because those objects are not required to test the thing you're testing right now, right? So we saw the behavior sensitivity and the data sensitivity. Okay, I showed you if you remember some time ago, the backdoor manipulation. I went to the database directly. I set up the test fixture, and then I exercised the system, and then I went to the backdoor to test it. Okay, the data sensitivity basically says if you're depending on this and somebody else changes the data, your test is going to get impacted by the change. a change in the data. Okay? And the last thing is the context sensitivity, right? Like I've been telling you about minimize the test context. Minimize the test context. Why? If all the test context, all the tests are require them, it's okay, right? It won't impact. If you have like sharing a large number of graph of objects and reusing across all the tests, even if you change just one of those things, a lot of tests are going to be brittle. They're going to break because there is dependency. And it's become very really difficult to actually pinpoint, okay, which tests are really impacted by which one, right? There is no clarity there. So you want to be careful how you actually share the context between the tests, okay? So we saw the bad tests. Now we want to see some good tests, and then we can start discussing about the stubs and marks. That probably will be the be almost like only 10-15 minutes away from after we finish that from doing our kata. So the good tests. So exception test. So let's say you are writing a test and your external Twitter client, Twitter web service goes down. They throw an exception, like service not available, or the whale comes when you're trying to access to the browser, but your web service, they're sending you a whale exception, right? If you want to really create that overloaded exception on the server, are you going to like send like thousands of requests to the real server and try to simulate it? It's too expensive, right? You want more control over certain things. You want to make impossible situations happen, like out of memory error, file system full, like those resources, right? And like what happens if somebody unplugs the network cable? Network is down, error. You can't really pull down a cable while the test is running, right? You want to simulate this exception, that's when you use a stub. Should throw this exception, should return this exception. You have those API to actually have more control. So you can make your code more robust, okay? So you always need to have the exception test. This is a good example for a good test. Isolate the system under test. We already saw, how we use marks to isolate. Isolation is a good thing. And we always depend on things which are more abstract. Then the direction of this pointing thing is always towards something which is more abstract. Having this layer architecture, dependencies are always going down, right? So and you replace this layer, it's all isolated, so you isolate the SUT. If you have this well-designed architecture, you can isolate the SUT easily and test them easily in isolation. If benefit of isolation is it allows you to run the test faster, okay? And it does not depend on the order in which you run the tests also. Minimize the test overlap. We discussed to some extent how the SUT, if you have overlapping SUT, you will have some tests which is covering same thing as some other tests. And we also discussed, when do you delete the test? Even if you have a test overlap, sometimes we may want to retain the test based on the value that it provides in terms of communication. Test should not introduce risk. Like the reason I've been saying no if statement, loops, all those things is because we don't want any of those logic to introduce risk. Whenever you have complicated things, then that can introduce risk in the code. You cannot, if you have conditionals, you cannot really assert, okay, this is the code path that this is going to go through for this particular scenario. It could take any code path. I don't know. It depends on the data set. So reduce the risk. How can you reduce the risk? That's how you actually test your own utility, have your own utility, and you test them separately, and then reuse them across all of your different tests once that is well tested, and you can depend on it. Bug repellent, bug repellent is basically defect localization. If there is a bug, actually in the code, I want a corresponding test to fail. So defects are localized. And also, whenever you have bugs coming in, you basically have the regression test. You also ask your question, okay, where else can this kind of thing happen? Similar thing can happen, so that you can actually increase that resistance towards the bugs actually.
Do you have any examples for it? Like I could correlate it to Cucumber. Let's say you mark any feature as a like bug number, and then you run it.
Let's put a simple thing like off by one error, for instance, right?
Okay.
So where else do you have this possibility of off by one error occurring? It's just a matter of, it's just a matter of making the code more robust. But it's like such a basic thing to overlook. It's a good idea to go and revisit your code and make sure you have coverage for those kind of scenarios. So you missed one boundary condition, for instance. What happens if the customer suddenly downgrades on 28th of February or a leap year or something? Oh, where else can this kind of error happen? It happens once every 11 years or something. But you need to, if it's so far out, you don't even have to worry. But if it's going to happen much more frequently, then you need to actually have a test, right? Sometimes it's the general concept, it may be applicable to so many different parts of the system. That's the part you've been working with. Maybe some other team has been working on those things. They need to be aware so that they can actually look into their code and fix it, right? It's more like a communication, Fully automated, yeah, we don't want any manual intervention. Test has to be self-checking. It has to say whether it passed or it failed. Green or red, just by looking at it, we need to know if some continuous integration server is running, it needs to be able to email you the report, right? Repeatable, we saw, no matter what the order of the test I ran, it should consistently give me the same result set every time I run. It should not depend on the data set I provide. It should be repeatable. And defect localization I already discussed. If something goes on in the production code, one aspect of it, I just want one test corresponding to that to fail. I don't want like hundreds of tests failing because of that. Okay, this robust test, it doesn't really mean the robust in the sense, some people define this robust test as, okay, test is passing for the right reason and it's failing for the right reason. No, it doesn't mean that. This is robust in the sense, test is robust if it fails for one reason and one reason only. If it changes something else which is not relevant, it should not fail. That is the definition of robust test, actually, as defined by Gerard Mazos, Kent Beck, those guys. The Optiva, there is another guy who defined the robust test as something else, but I don't consider that as a robust test, okay? So it seems to differ based on who is actually defining that. Focus test, yes, the test should be focused on testing one thing and one thing only, one concern, right? Don't test the view layer and the controller layer and the model layer, everything, and then it's just not focused. It's more like a distracted test. It should be clear. Assertion, I should have included this slide much before than I actually introduced the assertion, like all those things. Fixture, we actually talked. External fixture, you don't have to worry about this external fixture because most of the time you are going to use libraries like Factory Girl or something which is going to manage the fixture for you. So it's more like transparent. As a developer, it's transparent to you. You don't manage this thing manually. You just only need to know how to use nested context, how to minimize the test, how to remove the setup duplication, how many objects do you need. You have to create minimal number of objects that you can share across. Yes.
I'm not too familiar with the concept fixture.
Fixture, okay. Fixture is basically, before I can, let's say, I want to buy some books on Amazon, right? Amazon is like a black box. Before I can purchase the books, they need to have books in their inventory, right? I want to buy some software books. I'm interested in buying the Gerard Mazos XUnit test patterns, right? I'm searching. When I search it, I need to find it. Only if it's in the inventory, I can find it. Okay? So, what is the prerequisite, precondition of the system is the books that I am interested in should be in their inventory, in their database. Okay? In order for me to, let's say I want to test the search feature, the precondition is I need to create those objects in the database. So I can use FactoryGo, for instance, and create XCD test patterns book and then put it in the database. Those are the existing records. Those are the existing objects. Okay, those are persistent objects in the system. So if I do a search, if I come in as a user and I do a search for XCD test patterns, I need to see that as a result set. That is the expected outcome. Those systems should be in a certain state before I can start using it. So it needs to be in a certain state. That's where you create those objects. You really need a certain objects. For Fibonacci, some of you actually created an instance of Fibonacci, right? You did. Why? Because you need that object to call that number method. In this case, that fixture is that Fibonacci object he created. In the Amazon case, that's the book object I created. So that somebody searches, they are able to find it. So that they can interact, they can put it in the checking cart, they can check out, pay for it. The entire workflow depends on the precondition.
So basically the fake data you create during the setup.
Yes, that's the data, and that's the system needs to be in that state before you can invoke, for instance, add to a shopping cart. That's the thing I'm going to exercise. Before I can add to a shopping cart, I need a certain book
All
object.
the preconditions.
Right?
All the preconditions.
Yes, it's a precondition. In DBC terms, it's a precondition. And postcondition is in RSpec is implemented as expect. We will run through it. I'll show you that code. Okay, it's called expect. That's the expect whatever goes inside the block. That's the postcondition. Precondition, postcondition, invariant. I don't think there is invariant as such, but it's a invariant is more a DBC term. That's always true. So the outlines is basically whenever you have like a lot of things to test, you basically create, okay, this is testing Fibonacci, okay, you write outermost level, you put a comment, and then inner lesson under Fibonacci, I want to test this boundary condition for this, you put this thing. And then if you have something else at the same outer level, you put something else in there. You have some other specific thing, different scenario, different context. And then you put whatever you want to think. It's more like a commenting, and you want to, whatever you have in your mind, you want to capture in the text editor, and then you can start writing tests based on that. It's more like a structuring your tests, basically. Isolate test, we already saw this. Test list is like you have so many things to test, but you have to actually, you can capture everything and put pending, right? It should do something, it should do something. You can capture all of them. It's your laundry list of test list that you're going to work on. So you already know how to pick the first test, how to pick the next test, and how to actually do this. We already discussed whether you should do a test first. Test last results in actually code dictating what your test structure should be like. Test first, the main thing is like you want to drive the test, use the test first, actually drive the design of your code, so you basically have a minimalistic system. You don't speculate anything. You don't come up with the waste, right? Things that nobody uses. Your test is your first client, basically. We already solved this thing going backwards. Remember different techniques for writing tests. We wrote the assertion first. So if you're kind of stuck, I don't know how do I write this thing? Try to assert first. Okay, that has to be the post condition. Okay, in order to have this post condition, what method should I call? And what should be the test context? What's the minimal amount of objects I need before I can call this method? Because that method needs a precondition to be met before you can call it, right? And then test data, we already saw test context. How do you pick the test data? Sometimes the test data you use, you actually have to name it. See, if you have in your factory method, varied customer, say a valid user. I'll have valid user. I'll have invalid user. I name it invalid user in my factory. So when I'm using the test data, when I'm looking at it, I know I'm dealing with the invalid user scenario, invalid valid user scenario. Okay. So I have like a product, same thing. Product. This is a premium product or a premium customer. I name those data itself that I'm using, test data, meaningful, so that when I read the test code, it's easier for me to know. Okay, say I have a context attached to it. Okay. That's kind of like evident data. It's very evident just by looking at it, what it is. Child test, I kind of like told you this child test. You're writing, let's say you're writing one test, controller test, and I know it's like a thin controller, fat model. You're having a lot of logic in your controller. You know what? This is better to be moved to the model level. So that is a child test. That logic you moved in, you put this pending in your controller. You put the create a child test in your model, make that one pass, and then you go back to the pending test in your controller, and you make that one pass. Okay. So, okay. That is the crash test dummy. If you didn't figure out by this time, you can't really make a real customer sit there and crash the car and make them die, even if you're a prisoner or something, right? That's why you use crash test dummy and then you test everything, right? It's too expensive. Same thing in the software. Sometimes the resources are very expensive even though if they're available. That's when you actually use the crash test thing. I'll be going on stubs and marks in its own section, okay? Okay, what do you do when you're like TDing? I know like some of you guys do TDD just by yourself. And when you're programming alone and you're doing a TDD, how do you end the programming session? The answer is on the slide actually. With a broken test. This is actually taken from writer's habit, where the writers, by the end of the day, they leave a sentence incomplete. They come back next day, they start working on it's kind of like a bookmark. When you're reading a book, you have a bookmark. So when you're programming by yourself, you always have a broken test. So when you come back, you have a failing test for the right reason and you continue from there. It's your bookmark. Instead of, how in a Cucumber you always have like something, work in progress, or you could have like, bookmark kind of a thing. You can always go back and say, okay, this is what I'm going to work on next. So what do you do when you actually are TDing as part of a team? You have a pair programmer. How do you end the programming session? Answer is on the slide actually. You never leave it broken. You always check in when all the test passes, when you are working as a pair. Okay? So the one-to-many is like sometimes you have a data structure and you have a collection of some items or something you're testing, right? How do you deal with testing this? How should you go about testing this? First you write a test for one item, okay? And then you extend it to many items. You go from one to many. It's a one-to-many test. It's already refactoring. There are several ways to refactor. Refactor itself is like a big topic. You can just read the Martin Fowler's book. This is only going to cover reconcile differences. Like, you see actually two methods kind of similar, but they are different in a certain way. You gradually reconcile the differences. Because if you just abruptly do them, it's just going to break a lot of things. You need to gradually reconcile the differences. So you have to go step by step. So sometimes you want to isolate the change. So you have like a 10, 15 line code, and the first 4 lines of things is what you want to refactor, you want to actually isolate the chain by actually saying, okay, I'm going to have, this is kind of focused on doing one thing. Okay, I'm going to take the entire thing, hide it behind a really nasty, well-defined, actually private method. But the implementation is going to be nasty. But you're actually making that method, instead of 15 lines of code, you just want to have like 4 or 5 small methods, compose them of small methods. Okay.
Write the test for those methods.
Yes. Private methods, you can test them later and you can do whatever. But the private big methods, you just want to make sure it's easy to read and people can grab the things on the public API. You want to make sure, it's kind of like, it causes a lot of, you want to compose bigger methods out of smaller methods, private implementation, okay? And migrating data, sometimes this can be really a pain. You abruptly migrate the data, you can break a lot of things. So this kind of like, you keep the existing thing and you have a new thing, but there is a transition to actually go to the new thing as you gradually start writing more and more new tests. You don't abruptly go from dropping the old thing to the new thing. You gradually do it over, as you make more progress, you can make the transition even more bigger from the migrating the old data to the new one. So it's more like a gradual transition. Okay, those are some of the refactoring techniques, and we don't really have time to go to all the refactoring techniques, but this section is really important, stubs and mocks. So the stubbing basics. Now, a fake object can be, we already saw the crash test dummy. Okay, the fake object can be either a stub or a mock. So we go back to the same 4-phase canonical test structure. In the setup phase, I actually create a fake object. In the test environment, fake object is the one which is used. Setup phase also installs that fake object on the SUT. That's what it actually tells the SUT, hey, you need to use this fake object, not the real one. Okay. In the production system, this is the real object which is going to be used. And the setup actually is going to set up some data that this guy might need, and then you exercise the SUT. SUT is going to interact with the fake object from now on, instead of with the actual real component. And then you can verify it. Okay?
So this fake object is the stub or
It could be a stub, it could be a mock. Okay.
What about the fixture? Is the fixture
this is data. This is just a data. Picture is basically data, context, objects that the system needs. Okay, it needs to be in a certain state. You need to put this system in a certain state. That's what fixture is all about. Test context is all about.
So basically, fixtures are stub data instead of a real database. It's kind of like a stub database. Would that be?
This data can be, look, actually if you're using a library like Factory Girl, it's actually inserting records into the database. You're actually going to the database. Ideally, what you want though is, you want to be able, without hitting the database, you want the data to be residing in memory. Okay? And if you read one of those books like written by the Exynos pattern guys, in one of the projects what they did was, it's just a hash-based data structure. It's just in memory. All those database calls you're making, it seems as though you're going to a real database, but it's not. In test environment, it's going to the hash, chained hash in memory. So all the tests actually run faster, much faster, instead of hitting a real database.
So could it be like, let's say you need a user object?
Yes, this can be a user object, this can be a credit card object.
Yes, so just credit card or
anything that the system needs.
Yeah, so
Yes, stub the credit card, for instance.
And return any fake object?
Yes, fake object. Okay, here is the test stub. So instead of fake object, now I have a test stub. Stub, I create a test stub. I install it in the SUT so that when in the exercise phase, it's actually going to use the test stub instead of this dependent on component. And in the verify phase, you're going to verify whatever you need to verify. Okay? It's state verification. We already seen what the state verification is. What I want you to see though, see this indirect input? This indirect input is provided by the test stub. Okay, this indirect input is provided by the test stub. This test stub, think of this as tax calculator. It's a fake tax calculator. It won't really go to the database. If somebody tells you, okay, what is the calculation, you will just immediately return, okay, for this geographical location for this is 6%. Because you're programming it. If somebody gives you this input, you return this output. That's what you're saying.
So what is the difference between this and then the one before?
This fake object can stand in for anything. It could be a mark or a stub. See this? This fake object basically could be a test stub or a test mark object. The first one is just kind of like an introduction to how you create a fake object. You can actually do this thing. Now you are actually going into real programming. You're actually programming. Hey, somebody gives you, they're from California and they are purchasing 4 books with this much shipping weight. Return this. You're actually programming a canned input, canned response. Okay? You're actually programming it. You have more control over it. And in this case, asking, hey, what is the tax? When the shopping cart, for instance, is going to, SUT is the shopping cart, is asking what's the calculated tax. He's going to just, this guy is going to return all the programmed values. That's this arrow right here. Okay? Installs it, and next phase, this guy is going to get whatever this guy provides, and the verification, you do your verification. Okay? Now I want to quickly go through the how it looks like in the code. You have a book object. You are stubbing the title. The title is the name of the method, and this is what is returned. This is the RSpec book is the name of the title. So whenever you say book.title, it's going to return this guy. This is a different syntax, same thing. Third one is also explicitly saying same thing, okay? You can also do a double. What is this double? What does this thing have to do with the stub and a mark? Okay? Double is actually a terminology that Gerard Mezos came up with. He standardized all these terminologies being used. Everybody uses it in all their own different way. This double can actually be either a stub or a mark. This double is basically a fake object I showed you in the very first slide. Okay? And in this case, look, order.total. I'm stubbing the price of the book to this, and I'm having another stub price. I'm actually making that. If somebody calls this price method on it, I want to return this. If somebody calls the price on it, I want to return this. This order.total is going to loop through this collection, and it's going to call the price on each of this item, right? To me, this looks like this stub is like some product which has some price to it. So it's going to order, if you say call the total on it, it's going to loop through each of the price, it's going to add it. Okay? In this case, I'm going to take the Steam instance variable that holds a team object basically, okay? And players. If you call team.players, it's going to return a collection, okay? And each element in the collection is nothing but it's something that responds to this name, and it gives actual name of that guy. Okay. So the validator in this case, okay, here is the mark. This is what the mark looks like. I just showed you the stub. Validator is a double. Okay. I said double can be either a stub or a mark. It becomes a mark when you set the expectations on it. Validator should receive validate message with, this is the argument, okay? So validate will have this 02134 as an argument. All I'm saying is that this validator is going to be a mark basically, okay? And you create an instance of the zip code, and you see what I'm doing here, I'm passing the validator as one of the arguments to the constructor here. It's basically a dependency injection. So when I showed you in the slide where I said in the setup phase, I install the stub into the SUT. This is the installing the stub mark in the SUT in this case. Okay, is zip code valid? If I call this zip code valid, all I'm saying is I have here I create fake object. I set expectation here. This is another step. I create the SUT and I install the fake object on that SUT, and then I invoke the method. This is the exercise phase. Okay. Zipcode.valid, what should happen? There is no verification as such. This is similar to the three phase I showed you, where you set up, you have expect, and then you exercise. There is an implicit verification done by the RSpec framework. That's when you call valid, it should actually receive the validate with this parameter. Okay. If it did, the test will pass, otherwise it will fail. Okay. And here is another example of a person. Just focus only on, I'll be repeating the concept again, okay? Just focus only on the syntax of the RSpec for now. So I have a person, double, and then always it's a good practice to pass the string of the object you're actually stubbing or marking. In this case, it's a person object. So I'm saying person because this is what will give you the diagnostic message when something goes wrong, right? You'll know what object to look for. Okay, so this is a person, double, and then I'm going to stop the class method find class method on person class, and then return this stub value.
So
okay.
basically, it's creating a person object, fake person object, and then when somebody is finding person.
This person is not creating an actual person object. This is basically a fake object. This is a fake person object. This person is a real person class, like the active record. You're stubbing the class method find on it.
And returning that.
Yes, if somebody says find on this, just return this fake person
So
object.
instead of mock, we can use double.
What? Yes, you can use, instead of mock, here I'm using stub actually. I'm using stub only, okay?
So are both stubs? Each line
This is a stub.
Double, what is
This is
double?
a fake object. This is a fake object.
So
This
that's a stub?
Yeah, this I'm stubbing the find method only. It's a method level stub. Okay?
What is double?
But double you say could be a mock or a stub, so it's
Double can be either it can be either a stub or a mark. If I set expectation, it becomes a mark. Otherwise, if it's a canned value, canned response, it's a stub. Okay? I'm going to be going over this thing. Just bear with me.
Clear to me.
So
That's-
this-
I'll go over this thing again. I'll go over this thing again. For now, just focus only on the syntax of the RSpec, okay? I guarantee by the end of the time I go through, you'll be done. You'll know what it is. Basically, all you need to know is this is a fake object. Don't worry whether it's a stub or a mark. All I'm doing is I'm stubbing the method. It's a method level stub. All I'm saying, if somebody calls a find on this person, just return this fake double object, okay? Now, look what happened. Double should receive this message and return some value. When you set expectation on a fake object, in this case that's double object, it becomes a mark. This fake object is now a mark because I have set the expectation on it. Okay? Should receive this, and I also said it also has to return this value because it's important for me. It returns some value. Okay? So here is again, I'm going to actually walk you through this stub concept. It should become clear once I go through this. What I'm describing the statement object, okay, statement class. It uses the customer name in the header, okay, that's what I'm testing. It should use the customer name in the header. That's the focus test right now, okay. The first thing I'm doing is I'm creating a stub, okay. Just make it very simple, no double, no nothing and all that. It's very clear. The customer is a stub customer, and I'm passing in the string as customer so that I know when something fails, the diagnostics will be clear on that, okay? So, see what happens once I have the customer stub. What am I stubbing? I'm stubbing a name method on the customer and saying, if somebody calls a name on this stub, I want you to say, okay, it's a Joe customer. So whenever you call a name, it's always going to be a Joe customer, okay? So it's a stub. It's a canned input, canned response. I'm saying, okay, somebody calls this, return me this, okay? So I created a stub. I actually going to say, okay, Jokers, return this. I now actually creating an instance of the statement object and installing the stub on the SUT at this line right here. Okay? So from now on, the statement object is not going to actually interact with the real customer object. That's the DOC, it's gone. It only happens in production. In the test code, from now on, the statement is going to interact with the stub only. Okay? So now what am I doing here? Statement.header, this is the exercise phase. Okay? Statement.header is going to return a string for me. Okay? And that should be statement for Joe customer. Statement for, see this? This is the customer. That's the Joe customer. That the created the stub and as the canned response. So this statement header is nothing but this guy. Statement header that's generated is going to say statement for the customer name because internally it's calling the name on it. Okay, this is a why? Because this is how it's implemented. Calling the statement, create an instance of this, call the header on it. So I'm returning the statement for customer.name, but it's calling the stubs name method. I'm already programmed that name to return Joe customer.
Couldn't you make it more generic? Like, let's say the header changes, except you still know the customer name is in there, but it could be header for customer name. So wouldn't you want to use the equals tilde? What is it? Do you know what I mean? On the previous, so you're making it a little more generic. Instead of statement header should equal that.
Uh-huh.
Right.
You want a regex match? Yes, yes.
Yeah,
If it's going to a logger, for instance,
Uh-huh.
yes, I may do
Okay.
regex match. This is like, this example is more focused towards introducing to the stub concept.
Okay, sure.
Okay. Yes, you're right. If it's going to a logger, that will make more sense. Okay.
Okay.
I have a question just about the syntax of the stub. Like
Yeah.
the first line stub,
Yes.
customer in quote.
Yes.
So the so we pass into the stub
It
is
doesn't-
the name of the class.
It doesn't really depend on what you pass in here, but it's good practice to pass in the name of the thing that you're stubbing because that's what provides you the diagnostics when something fails in the test. Okay, it's always a good practice.
But it's not
You don't
really
really have to pass in even a string. You can just say stub.
I see.
Yeah, without any argument, it will still be a stub. But it's a good practice to pass in what you're actually stubbing.
I see. Therefore, it's passed in as a string because
Yes.
it'll be used in diagnostic.
In the
message.
diagnostic, that's the main purpose. Okay.
Okay.
So when do we use stubs? I was saying, okay, Mike, right? Okay, Mike is working on a particular object and I am also working on some other project, but I need to use his stuff. But in parallel, we need to work. He's not done yet. I want to use it. Let's say he's actually, if that's the case, I need to use a mock or stub because it's not available yet. Another case is his object is available. Mike has everything is done. He's ahead of schedule. But setup is very expensive. It's makes my test run slow. It's very expensive. Then I really cannot use the real object. I want my test to be faster. So how would you simulate something like this? Even if you want to simulate this, it's going to be really, really expensive, right? So that's where it's applicable to use stubs, basically.
But then in the last
You have more control, right?
Got you. But then in the last case, you were setting the name. Let's say you created the customer class, and then you were stubbing the name. Wouldn't it be?
Yes, you can do that. Yes, you can just look customer instead of stub customer. You can say customer.new.
Uh-huh.
You can actually stub a real object. Yes, you can do that. A real object can also be stubbed. In that case, you can just you'll just say customer.new. It's an empty object, and then you just say that customer stub the name and then return this. Okay.
Can we do like customer equals to stub customer and then say customer.name equals to Joe customer? Can we do like this?
Customer. No, that's not the syntax.
That's not.
No, it's kind of like very, very explicit. When you need, they want this thing to read, it's like a poetry. So the way you think is like customer.name equals something.
Assign the name.
Assigning, yeah. That syntax is not allowed. If you go back to a lot of slides before, I showed you 3 different ways of doing the same thing. That syntax was not there. One is using the hash rocket.
No. Yeah, I said.
Yeah, so yeah, those are the three different ways to do the same thing, but that syntax is not, I don't think is allowed.
You shouldn't read like a code, you should read like a sentence.
So, see, I said, those are expensive and you want to isolate from those external, environment, right? The zero gravity is what you need. I cannot provide you that because it's too expensive. You want to isolate your objects from those expensive resources. Stub is the one way to accomplish that. Okay, and another thing that's where this is helpful is you have non-deterministic values. Like not only things I don't have control over, you have like system services, like I said, time, day, things which is always moving, but you cannot really make the test run at a specific time. Even the random values, this is a non-deterministic behavior, right? In this test allows move to last square. It's a mini test built in Ruby thing. You create a board that has 50 squares, and the die is basically board as a die. If you call the die method, it's going to return a mark. Okay, that mark has a roll method. It's going to expect the roll. When you say expect, it is going to respond to roll, and it's going to return 2 always. So non-deterministic thing has been made deterministic. Okay, I have isolated that non-deterministic thing so that tests become repeatable. Okay, once I created this board object, now I have a piece. I created a new piece. All I'm trying to test is like if I'm on the 48th move, if I move 2 things, I need to be on the 50th 50th box basically. Okay, so board.place on the 48th square, board.move that piece, and then when you do that, board.move, this is internally going to call the die thing, it's implementation thing, okay? And then it's just checking the board.squares of this should be 50, contains of 50, because this should have moved 2 pieces, okay? It's kind of like a bug in the code. So you can isolate the the non-determinism. Now this time you want more control over the time. You can't really be dependent on your test being running at midnight every night because you want to run anytime. So in this case, you're describing an event. It's not happening before the start time. It should not be happening before the start time. Okay, anything before the start time, the event is not begun yet. So time is time.now, which is like let's say 5 p.m. Start is now plus 1, which is like 6 in the future, right? Start time is going to be in the 1 hour future, okay? Look what I'm doing here, time.stub now. I'm stubbing the real time object in Ruby. Like you were asking me, can I do a customer.new and stub? I'm stubbing the real object here, which is system time, and I'm stubbing this class method, right? Just like I did the person.find stub, I'm doing a built-in Ruby object, not now, and then return now. When somebody calls now, whenever this test runs, it will always is whatever this thing was, okay? Whenever this thing ran, it will return 5 p.m., okay? The event that start is, it's always 1 hour before. So it's always going to be like 1 hour after what is now, right? So event should not be happening. Basically, this is like aspect thing. Whenever you have something b underscore, it means it expects happening question mark in your event class. You need to implement the happening question mark. That's either going to return true or false. Okay, so event should not be happening. Basically, all I want you to focus on is like we are getting rid of the dependency on the time by using the stub. Stub is used for non-deterministic. If you want to make something which is non-deterministic, which has dependency on the randomness, random behavior, or dependency on the system services like clock, time, dates, those kind of things. We break those dependencies by canned responses to whatever input. We have more control over the responses that it's actually giving. Okay, so it isolates us from those external dependencies. We achieved isolation. See, again, isolation from the network, going over the network. I don't want my unit test to be hitting the network. So in this case, look at this network access. In this case, I'm actually using the test mode of the active merchant billing. I'm giving the login password and the my login login as well as the password. My credential is given. I'm creating a stub, which is an item. This is some item that I'm going to purchase, and the mark is some messenger. Okay, when I purchase an item and I pay for it, that item should be shipped to me, right? So it says, okay, messenger should expect ship that item, that particular item, okay? Because that item is kind of like, okay, this customer has been successfully charged, he needs to be shipped. It's somebody else's responsibility to ship it. But I just want to make sure that outgoing message is sent. Okay, that's how I set the expectation here on this particular mark. And I just say purchase that new. This is my business object. It's going to take the gateway. In this case, is the active merchant billing gateway. Okay, it's going to go through that payment gateway, and it's going to charge for this item on this credit card for this customer, and it's going to this messenger, which basically going to handle the fulfillment aspect of it. Okay, and here is I actually do the exercise purchase.finalize. So what happens in the purchase.finalize is actually going to go over the network in the test sandbox mode, and it's doing its thing. It's going over the network and doing all this stuff. But once that is validated and it returns me the true or false according to the logic here. Okay, the payment was success, and then this messenger is going to interact with the ship. Basically, it's going to ship that particular item. That's how I know, okay, when the purchase is successful, customer has been shipped the item and the test passes. But this test, there is no gateway. You're not going over the network anymore. See how we have stubbed the gateway. Gateway is just a stub. In this case, we are not giving a string, remember, right?
How come
Yeah,
it is stub
because,
and not
yeah.
just stubs?
Yeah, this is just a stub. This probably is a mini test thing. Look, this is test. It's not a RSpec thing. See, test successful shipping purchase. So this is Mocha or Stubba. They are using a different library. The syntax is different. Okay, but the concept is the same. So gateway stub, you can actually pass in a string to make sure it's a gateway. Gateway stub, see authorize method. So what is this authorize method? It's a instance method. And it's going to return this active merchant billing response new, because this is what we need in order to say, okay, this purchase was successful, because it's based on the return value. Okay, so I have say item is a stub. I don't really care about the item. All I care about right now is C. It's in the test. Successful purchase sends shipping message. So the behavior is what I'm actually concerned about. I'm concerned only about, okay, successful purchase. I need to ship the item to the customer. It's really important to make sure the customer gets the item once he has been charged successfully. That's the main focus of the entire test. So everything else is irrelevant. That's why I'm stubbing the item, because I don't really care what the item is. I don't even care what the messenger is. All I need to make sure is the messenger is going to receive the ship message with this particular item, because that item is the one that needs to be shipped, because it does matter to me. I ship the right item to the customer once he has been successfully charged. Okay, purchase.new, and you have the similar way that we did before. Purchase object is going to take the gateway, item, credit card, messenger, and this is going to say purchase finalized. That's actually going to charge the customer on that credit card and for that item, whatever the total amount is, and the messenger ship is going to get called behind the scenes. It's the indirect output that I've been showing you in all the slides before. It's the indirect output, and the only way to verify is to set this expectation. At the end of it, there is no explicit verification on the mark. It doesn't say mark.verify. In .NET you will do that. In Java you do that. In RSpec you don't do that. It's the implicit verification.
By the system?
Yes, the RSpec framework does it for you. So if you don't receive this ship message, the test will fail.
So is it like should receive?
Yes, it should receive. Should receive. It's using a different library, okay?
So just looking at the slide, the difference between a stub and a mock. So for example, gateway stub and messenger mock. So a stub defines a predetermined return value of a call, whereas mock defines a behavior, a predetermined behavior of a call, right? Because
Almost right.
gateways.
Almost right. Mark can also, you can program the mark to return value also. If I go back to few more slides, actually I showed you an example when I was showing the syntax. Remember, person.find with this return something.
That was
Right.
a mock.
It should receive something.
So a mock is a stub with an expectation
Yes.
that something is called.
That's a more
With
accurate
expectation
definition.
of something is called.
You can only set expectations on a mark. You cannot set an expectation on a stub. Okay, that's one thing.
But that's just semantics, isn't it?
No, stubs, marks are not stubs.
Because, say for instance, you may stub something out, but it's never called. You wouldn't know that unless you tell the mock to expect that it is called. For instance, in the case here, if you just stubbed it, you may not know that the item was never, the messenger was never said ship. If you just stubbed it, it may never be shipped. You may have a bug that you're not actually shipping things.
Customer should
That
get
means you
it.
can call
Yeah.
something on mock, but then you cannot call on something on stubbed object.
You can call it, but you can't make the framework require that it's called. Because if the ship message isn't received by that messenger,
It will fail.
it will fail. And that mock does that. A stub will just return a fake answer, but you have no guarantee that it was ever called. So you might have a bug that purchase new, the purchase isn't actually shipping. The mock says you have to call ship on
It's very strict.
Yeah.
See, stub can never fail your test. Marks can fail your test. And he explained you.
But mock has, this
How?
mock statement has, mock expect statement has two parts. It
Yes.
requires the ship method to be called. It also
With this particular
requires-
item.
It tells you what
It
to return
also-
when it is.
It also defines the expected
Yeah.
behavior of this call.
Not the expected, the canned response it gives. When you call ship on the messenger, it will give you item. No, sorry.
Finalize.
You're right. It expects item to be given to ship
Right.
as a parameter. You're right. You're
So
right.
specify both the calls and
That it is
expected.
called and what
Yes,
it's called.
with that particular
where-
argument.
Where stub just
Stub is a canned input, canned output. You have more control over, what goes in it. You can have a stub credit card, basically. It's a fake credit card, Right? For instance, you don't really need a real credit card to test your system, for instance.
Let's say if I would have written messenger equals to stub, and then if I say messenger.expect, it won't fail.
No, because stub can never fail a test. Only marks can fail a test. You can only set expectations on marks. Okay, stubs and marks are two different concepts. Marks are not stubs. Read Martin Fowler's paper. He has a paper on his website, martinfowler.com.
Which one?
Okay, martinfowler.com. Okay, this confusion was started because of all this RSpec library not distinguishing the difference between stub and a mark. And then David Kemlinski actually realized, you know what, let's stick with the Gerard Mazur's terminology and use the double. And when you use the double, it's a fake object basically. Crash test dummy I was talking to you about. Double can be either a stub or a mark. If you set expectation on the double, it becomes a mark. If you don't, it's basically a stub. And you cannot program a mark to return a value. You can. You can set expectation. I can actually say message expects this with this and return something. It will return that something.
but that's just a limited case.
Yes, that's like what I was trying to get at is like you cannot say that as a distinguishing factor. Okay?
So is messenger mocking a messenger object?
Yes.
Okay.
That's basically your fulfillment system. Something is going to fulfill.
And then
It's
with,
pretending to be your messenger.
Yes.
okay.
It's intercepting all the calls to a real messenger. It's a fake messenger basically. It's not going to really ship anything to anybody. It just makes that outgoing message is outgoing. You've been looking at the outgoing message from an object. This is an outgoing message. So
then
basically this guy.
What's passing ship an item to messenger? Is it the purchase new method?
Purchase that finalized, it's all the implementation details.
Okay.
It's a side effect. If you want to think about this, it's a side effect.
Okay.
All the side effects I want to use marks to test the side effect. If it's a state verification, I know it's a result set coming, I'm checking the state. I don't need to use double mark for that. It's basically state verification. It's not behavior verification.
Okay.
Behavior verification is all about side effects. Behavior verification is what the setting expectation and mark is all about.
So purchase finalize, the side effect of that is to change.
Yes, exactly.
Okay.
Did you see that hidden behind the curtain thing, the hidden messages? The ship message is going to another dependent on component that's going to take care of the fulfillment.
Okay.
Okay, that item is going to be shipped to that particular customer, but we do care that's being done.
Mm-hmm.
I will test whether it's actually doing a job in a separate test, because it's an incoming message to another fulfillment object, and I will test as part of the public API of that particular object. Okay, and I'll make sure it's really doing the job and it's working. But the focus of this test is somebody successfully purchases something, I just need to make sure they get a shipping, they get sent shipping. I just assume the other object is fulfilling his responsibility. My responsibility is if I need to send the credit card of this customer with this item, with this payment to the payment gateway, and I want to finalize the purchase. Successfully, if that scenario is handled, I need to make sure this customer gets that item shipped. That's it. Whether it's actually getting shipped or not is part of our other test. Okay, that's not the concern of this test. It's very focused. Things they've been talking the entire day, being clear, focused, testing one thing at a time, one thing only. Here is an example. That's just what it needs to do. Minimal
you have to
amount.
always pass the string in mock or stub, or it can be blank, like mock, blank, without any string.
No, in this case, you don't. Even in RSpec, you don't have to pass string. It's a good practice to pass a string because in the diagnostic messages, you will be able to see if something goes wrong.
In this test, what happens if you don't have the last two lines with purchase and purchase dot finalize? What happens?
That's a very good question. Okay, let's go back to the original slide I have set up. These are all like setup code. These are all like see, certain things I need before I can start. This is the exercise phase. Okay, this is the exercise phase.
So expect it's also.
There is no verification. Fourth state, there is no verification. There is the exercise phase. There is creating this object is part of the context setup. Okay, this setup I'm actually creating the SUT, and I'm actually passing all the argument it requires. And I'm also installing the mark. Look, messenger is a mark. Stub is also another stub that it requires. It uses stub as well as mark. Okay, I'm installing stub as well as mark on the SUT. I create a SUT. I install them using dependency injection. So these marks and stubs are what is going to actually intercept all the calls. That's going to happen, not the real dependent on component, which will be used in the actual production system. Okay, so each one is a different. This is the exercise phase. This is the setup phase. This is all the context. This is all like fixture. Okay, because of the purchase finalized, internally the implementation is going to call the authorize because we want to first authorize before you charge the customer. Authorize. Oh, okay. Everything is fine, his credit card is fine, everything, look, this credit card is valid, authorize will return true. They will return this particular thing, actually. Okay?
So everything except the last line is part of setup?
This is all like, yes, this is all like creating the stub.
Okay.
Let me go back to previous slides. I'll actually kind of show you how it relates. Okay? Okay, here is the stub part. Okay, in the setup, you see what we did. We create the stub. Item is it's setup phase. You create the item stub, and not only test stub, we also have another mark. Also, we are creating that again another mark which is behind messenger mark. We are creating two things in the setup phase. Installation is when I actually create an instance of the SUT. That is the payment purchase object. That is the SUT here. And installation is nothing but I'm passing in as an argument to the constructor. It's a dependency injection. So which means, hey, purchase, use this test tab and use this mock object instead of the real messenger or the real item, okay? Because those things are irrelevant details. I don't care what they are, okay? I only want to emphasize when I exercise the finalize on the purchase object,
So in this
you
case,
need to send an output called ship. You need to send the ship with that particular item to somebody, to this particular
So in
customer.
this case, in the code, that last line, purchase.finalize, that's the exercise part.
Yes.
So if you leave that line out,
Nothing, it won't
test
work.
case, nothing.
Nothing will
Our
work.
spec will just tell you to invalid test case, or just
It will just pass, you
It'll
know,
just pass?
it will just pass. Without assertion,
It
it
will
will
just
just go
pass?
through. Yes. It will
Wait.
just go through.
Well, it depends on what the shipping item value is, I guess, right? If by default it matches what you're expecting, it'll pass. I guess.
If you don't have this purchase that finalize, if you don't exercise the system, you're not making an assertion, it'll just go through, it'll just say no failure.
you only have a setup of a test, which you never exercise, so there's nothing.
You don't explicitly say mark.verify also. If you have to say mark.verify, like other languages require you to do that, explicitly call the mark.verify, that's when it actually will run. But in this case, it's implicit thing. It's
So
kind
it's
of
a good idea to always explicitly say a verify, so that you avoid this kind of.
It's more of a personal preference rather than standard practice. The RSpec designers just decided, okay, we are just going to make it implicit. Okay, it takes me so much energy for me to explain. Hey, it's an implicit thing. For advanced people, oh, okay, I get this. But the thing is, like, if you say step 1, 2, 3, 4, and suddenly the verification state, you don't have mark.verify. It's like, I don't have a framework to fit into this, right? It kind of throws you off. If you don't have this exercise phase is what actually kicks off that implicit checking of that mark.verify is internally called, whether it's caught the shipping message or not.
Can you go back to last slide?
The next one.
Last one. It's just before that.
This one, yeah.
This one is actually going to go to the actual payment gateway. Look, the active merchant billing mode is test. So it's going to hit the sandbox of active merchant sandbox. Not the active merchant sandbox, the trust commerce gateway. That sandbox is going to go over the network. We don't want that.
Okay.
We don't want that in the unit test. We may want to do that in the integration test. Yes,
How do you
we do.
How do you know that it is returning true or false?
This guy?
Yeah. In the next slide, you're stubbing this call, and you're returning true and ignoring.
Yes,
So
I'm
it's
like,
very
this is the
strict.
canned response object. So I'm just saying, hey, yes, the customer is not even hitting the network, it's not even hitting the trust commerce. It just says, it's just faking actually. It's a fake object fakes. So it's saying, hey, yes, I did charge the customer, because the point is not really making sure the customer has been successfully charged or not. Given that, precondition is given that successfully the customer has been charged on his credit card, did I ship the item to the customer? That is the focus of this test. Okay?
No, what my question is, you're writing it true. How did you know that it should return true?
Because I am the one programming it. I am faking it. Hey, assume this is the test. This is the test part of test context. Given this context, even it's successful, let's just assume that what's coming back is I'm just faking it. Hey, I'm saying, hey, don't hit the real test sandbags. Don't even go over the network. If somebody calls this, just say, hey, yes, I charged them. Because testing the customer was charged successfully or not is part of some other test. That's not the focus of this test. Okay? That's why this is part of.
Should we write a different test for testing the service, or should we leave it aside?
Which service?
This authorization service.
Authorized
Do
service.
we have to write any tests in our spec?
Because this stub authorize is indirect input that this guy is going to require. That's why I'm having to program. If you see some of the slides I've been going through, See, the dependent on component I've been showing, it provides the indirect input. I showed you direct input that you provide, actually the programmer provides. Behind the scenes, you cannot see. The reason you cannot see is part of the implementation. When it calls, when it finalizes, actually internally is going to do something, and it's going to call the authorize on it. When the authorize is called, it depends on this particular what it is returning. This guy is what is required. Based on this is what I am forcing a specific code path to go through. Okay,
But
this is a
my
successful
question is,
course.
how do you know that the service is like correct? You are stubbing it anyway.
Yeah, I'm subbing it because I'm simulating a successful charging of a
Yeah,
customer.
but then will you be writing a different test for?
Yes, exactly. Yes. Authorize, very good point. I will do authorize is actually authorizing it as part of a different test. If you see this, the focus is only on
The
shipping,
shipping, yeah.
so that authorizing will be a different test. Yes. If you see, every test is focused on doing one thing and one thing only. Okay.
And one more thing, how would that work? I see here 2 stubs and 1 mock,
Mhm.
but 4 things. Credit card is what?
Yes, you found a bag.
Something.
Yes, you found a bag in the slide. You just assume that's also a stub, basically. It has to be a stub if it's going to be. Okay, that's a very, very good point. Nobody noticed this thing, actually.
I did.
before you.
Nobody.
They were not paying any attention.
I know. That's okay.
You're saying the credit card is not initialized, right? We just
Not stub, not mock, what is it?
Yeah.
Credit card, no credit
It's a
card.
credit
No.
card. It's a fake credit card. It's a fake credit card. Okay, so we saw how we can isolate the time, randomness, and going over the network so you don't have slow tests, right? So now we are going to look at the collaborators, shift whites, all this, we have been talking about this, the duck typing and all that. This polymorphic collaborator is all about duck typing. I've been talking about the roles, how we can switch roles and compose objects in different way and reuse in different contexts. The reuse is what we are trying to achieve, right? So here is another code example. So here is an employee. It delegates pay to payment strategy. Okay, I create a mock. It's called payment strategy. Okay, here is creating a mock, and here is the creating the SUT and installing this mock on the SUT. Okay, and here is the setting expectation on it, and then here is the exercise phase. This is similar to the slide I showed you where I have a setup, I have an expect, and I have exercise. That's it. You have a setup, you have an expect, and you have exercise. That's it. Okay? So what will happen in this case? Payment strategy, it says delegates pay to payment strategy. So the payment strategy, somebody is going to call pay on it. Who? Employee. So payment strategy has to get this pay method. Okay? So employee.pay. Employee should not pay himself. He's going to defer that to the payment strategy. If he doesn't, this test will fail. Because the payment strategy mark will fail and the test will fail. So this is only involving just mark. Okay? I showed one example where you only had test stub. Here is only thing where you have just mark alone. No stub and mark has been combined. Okay? This is a 3-phase thing I showed you in the morning. And here's the question that he had in the morning. I'm going to actually go over this thing right now. So you have age identifiable, okay? And you're describing whether that person can vote or not. It raises exception if including does not respond to birth date, okay? You create an object, it's just a plain, it's just a regular object, Ruby object, and you're extending that with this age identifiable. This is actually a module. Module age identifiable, it's your own module, okay? And you have certain...
that module has
that,
can vote method.
yes, it has a can vote method on it. So
Awesome.
this expect is basically a post condition check. This is the post condition check. You're creating an object, you're extending with this age identifier module, you're mixing in all the behavior of this age identifier into this object. And this post condition check, once you mix in, this object now can respond to can word. If you can word, it should raise error, must apply a birth date. Now we have like a regular expression like you were saying, because you have not set a birth date for this guy yet, so he's not really valid to work. It's going to throw exception. Okay, that's part of the contract to raise error. If it throws exception with this error message in it, that's fine. We pass the test. Okay, that post condition check is valid and we pass this test. Second test, I create an object and this stub, this particular object, I'm going to stub the birth date on it. Okay, and it's going to return, okay, what is your birth date on the stub? It's going to say 18 years ago. I'm like at least 18 years old. So in that case, if I mix in this age identifiable thing, object word should be true. Okay. So which means, yeah, you're old enough to vote. Okay. It will respond to that message. It won't throw any error message. So what I want you to see is this is the creating of the actual thing. You're mixing in the behavior. Like your question was related to the Rails thing, right? If it's a Rails, if instead of a regular object, you can just create your persistent object, whatever object you have, extending from active record, right? You can either mix in the as guy, or you can just mix in a regular object also. You don't really need an active record object. That is the point. So it will make your test run faster. You can run this thing outside of Rails.
Okay, so instead of object, there will be, let's say, any class. User class would be there, and user class is in the Ruby code is extending this.
Yeah, you can just say user.new, and then you can just user.extend age identifiable. Boom. And you'll mix in the behavior, and then you can check, and then you can stub whatever you want in order to force the positive code path, right? This is the positive code path. I don't really care if this guy is 18 years old or not. I'm just setting these into old enough so that he can respond to the can word method should return true. That's more important for me. If he's old enough to word, it should return true. That's what I'm actually focused here, okay? So this entire thing does not require, it does not require any active record. It does not do, you don't need to do all the require there. So it won't slow down your test. It will run faster. So create, extend this, and exercise. Exercise and verification is combined into one step here if you notice, okay? This thing is exercise. If you exercise this, I expect something to happen. So this is more like a raising error. Exception is merely a post condition check, okay?
What's the mixin? Is that the object?
Mixin is basically a way for you to share behavior. You can mix in any module into classes so that you can share there is no multiple inheritance in Ruby, right? Mm-hmm. The only way you can share code instead of doing a multiple inheritance across all the classes is by doing extend of whatever module you have. You have a set of methods and you can share across any classes you want. Okay, the thing I've been talking about, roles. I've been talking about roles. If you have this person playing the role of a student, parent, all those things, you have a method. Student study, pay attention. Those methods in your module, student, and you can have all those methods. You can mix into a person, you can mix into a bird object, you can mix into any object. Now you have more flexibility. And you can compose person object to interact in a certain way. I can also send a bird object as long as it mixes in that behavior. Okay. It doesn't care. Because of duck typing, it will just work, right? It's all polymorphic.
Another question. You said whenever we are expecting something, we should mock it, right? And then you are stubbing object and then calling can vote on it.
Mm-hmm. Okay, returns true if birth date is 18 years ago. My only concern is if the person is old enough to vote, the can vote should return true. Okay? So this happens to be incidental. I am forcing a certain code path. This is the positive. This is the pathological case, like you were talking about. Whereas this is the happy path. Oh, you're old enough to vote, and now we can vote. The can vote. SUT is the can vote method in this case. That one thing is what I'm testing. It's small enough. Okay. Given that a user is old enough to vote, have you implemented the can vote such that it returns true if they're old enough to vote? That is the question. Okay.
I just wanted to add, I think he's stubbing birth date, not the object.
No. Yes, I'm stubbing the birth date. Yeah, that's right. Sorry.
Sorry.
Okay.
Stubbing the birth date,
Sorry.
not the object.
Thank you.
It's more like a this is more like a syntax thing. It's kind of like throws
It
people
is
off.
confusing.
Yes,
Yeah.
this is like a.
So in the second case, there's the second test case. There's only a stub.
Think
there's
of
no mock.
think
In
of
the
think
first
of
one, there's a mock but no stub.
yes. Think of this as object.stub object.stub
Birth date.
colon birth date symbol and returns. Okay. Yes.
Return,
Yes.
so-
Syntax wise, as long as you know what it is, it's okay. What was your point
My
again?
question, my point is, so the second test case has a stub but doesn't have a mock. You're not using mock here.
No, I'm
but
not
the
using
first
mock.
one you're using a mock because to expect, or that's just a.
There is no
solution
mock here
syntax.
as well. Where is the mock here?
Oh
Yeah,
no, I
there
just
is.
got thrown away by the keyword expect.
Oh, this expect is.
That's an assertion.
No, it's not setting an expectation on a mark. It is actually a post condition check.
That's what your test is checking.
Whatever
Right,
you,
right.
what
So
it
it's
means is
assertion kind of.
you expect whatever happens within this block to raise error. That's what you're saying.
Okay.
You're not setting expectation. No, it does not. It's not. Yes, it's
just the
confusing.
same word, but
Yes.
it's not a mock.
Yes, expect is a bad, confusing. Yeah.
So it's
Yes,
like an
that's a good-
assertion. Just
Yeah, it's like an assertion.
Yes, it's more like a. It's a. I think of it as a post condition check. So yes, it's more like a assertion. Yes.
Voila. In
Yes.
the second test, so you're stubbing birth date, and then you're extending age identifiable. Shouldn't the extending of age identifiable come first, and then you stub the birth date? You know
No,
what I mean?
no, it doesn't really matter whether you have this thing before this or after this. You know
Oh, it
why?
doesn't?
If you're gonna extend this, you're gonna extend the behavior of the object with this guy. You're gonna mix in that. Okay.
Because birth date, I'm assuming, is an attribute of age identifiable, right?
It's not an attribute of the object. So if you stub it before you extend
Oh,
the
I see.
identifiable
You know what I mean?
wouldn't work.
Because age identifiable will have a property birth date, right?
Whereas the object doesn't.
But if you extend it first, it's going to have birth
Right,
date
right.
then.
No, I think age identifiable has can both, and then object has birth date.
Object has birth date too.
Yeah. Object has birth date attribute, and age identifiable
But-
has can
Wait. Object, are we talking about
Age
the core Ruby
identifiable.
class object?
No, it is any object like user class.
I
User, okay.
Yeah,
Wow.
object is like he.
Yes, think of as a user. It's a lot
Any
easier.
class, like
So
any
Yes.
object,
you're not thinking about the core Ruby
Core, no, it's not
object.
core,
No, no, no.
The object.
Can
no.
vote?
Here is the
can
thing.
Vote cannot be before age identifiable.
That's actually a very good question. But in order to prevent the confusion, what you're saying is right. Think of it as a user.
Yeah.
Its birth date is part attribute in the user. Think of it as like active record. It will be a lot simpler because
Okay.
the reason he is using object.new is because you don't really need any special objects in order for you to stub something. You can stub a real existing any class. That's the point, okay? You can even actually take a string.new and you can start stubbing on it and extending them and mixing in and doing all that stuff. But here's the thing: if you're having an active record with certain attributes, when you have your own module, your method is actually going to depend on the attributes that's in your user model, like username, email, word, this birth date. So there is an interaction between. There is a certain things assumed there. So you cannot just mix into any bird object or a user object. It needs to have. It has to obey certain contract, basically. Okay. As long as you fulfill your responsibility, I can mix in. and I can offer this behavior so I can share the code with this particular bird object or a person object or any of those things.
So in this case, if you're using an active record and it doesn't have this birthday attribute, then you wouldn't be able
Yes,
to
you won't be able to do it. Yes.
stub it.
Yes. So there is a coupling there. Yes. There is a coupling.
Because the can vote method is going to look at the birth date.
Yes, internally implementation. Yes. Because the implementation detail say if birth date is less 18 years ago, yes, he is old enough. Otherwise, I'm going to return true.
Okay.
Right? So we saw stubs. Now we need to handle the mocks.
How long we have for the test?
Probably we are like close 15 minutes or so. So mock object, actually we will quickly go over this thing. Mock object is really important. So setup, you create the mock object. One thing you can see is it's very similar to previous slides in the sense we have the installation under the SUT and the exercise. And in Java you can do a final verification explicitly, okay? But in RSpec, this is going to be like implicit verification. There is no mock.verify. You set expectations here itself. When you install, once you create, you set the expectations on the mock. You install it on SUT, you exercise, this will be missing, okay? This won't be there because of the implicit checking. Okay, the same example that we saw before, we have a stub customer, stub the name, return customer Joe. We create stub, we have set programming to return a canned response. We have a logger called mock logger. The focus here is logs the message when printed, okay? So logger is a primary collaborator right now, okay? Logger, we create the SUT, we install the stub and the mock. Now we set the expectations on it. Logger should receive log with Joe customer, like you were saying. Now the logger is going to a log file, I want to have a partial match on it. Here is the exercise space. Okay? So let me break this thing down. I had a lot of questions previously, so I have broken this thing down even further. Statement.print will actually exercise, and the log message should receive with that particular string in order to pass. Okay? So we have a statement, customer and logger. Statement is the SUT. Why is it SUT? Because that's what I have in the doc string. That's what we are testing, okay? Okay, statement is the system under test. Primary collaborator is the logger. Why is that so? Because that's what I care about. I only care about this logger receiving the log statement with the string. That's what I'm testing. Logs the message when printed. Printed is where when I'm exercising it, okay? So we have statement, which is the SUT. We have a logger, which is a primary collaborator. This is a secondary collaborator. This guy is just playing a second fiddle. He's like a vice captain of a team. He's not really there to do any real job. Okay? So we have a sequence diagram where we have the first one where the statement, I call the print, right? Statement.print, right? It's interacting with the customer. Customer is going to give you the Joe customer. It just happens to need the Joe customer in order to actually dump the Joe customer into the logger. I just need this. This is the indirect input that is required from the stub that we have been going through different slides. Okay, this is the incidental interaction. This is the essential interaction. This is what I care about. That's why it's essential. Incidental just happens to be there in order to give me this output that I need for this essential interaction to happen. That's going to go to the logger. Okay, that's why I'm setting expectation on the logger mock in my code. Okay, look, logger mock logger is installed. I set the expectation on it, and I exercise the SUT. Okay, this guy is just playing the second fiddle here. He's not really doing much. He's just there to provide that indirect input this guy needs so that Joe customer goes into the logger. Okay. So this guy is just showing you can also just use object instead of using a stub and like this kind of a thing. You can also just create a regular object like this, and you can stub them, and then you can install them, and you can just say log setting a message expectations. Okay.
So the mock expectation doesn't always use the keyword expect. In this case, it used the keyword should receive.
Because this is RSpec. The one I showed you was mini tests, like a Ruby's built-in thing. It's using mock or stubbar, different mocking library. That's why the syntax was different. Okay.
Okay, but should receive can also be like a standard assertion, like RSpec assertion.
No. No, should receive is the way you set expectations on a mock.
So what's going to happen when you call a statement.print? It is like logger would get called and logger would be calling log method.
Yes,
so you
logger will.
Say first like that logger class, the log method from logger class would get called when you call statement.print. So you set up your expectation before the call.
Because this should, this syntax is very similar to the assertion statements.
Should
so
be,
so I get confused which one is the mock expectation and which one is the assertion. I mean,
When you have a
same
mock,
mistake earlier
Yeah,
in
well,
the
the
view.
should receive
is
the
setting the expectation.
mock expectation.
Yeah.
The should be or should, whatever.
Those
That's
are-
just the assertion.
Should receive is the syntax for
Mm.
RSpec. So it's a
Okay.
different.
Expect is not the expect is actually a method name that's used the post condition check. It's I know it's not properly named. Okay.
I get
Is the
confused
RSpec
which
guys?
one is RSpec,
Yes.
which one is mock.
Yes, it creates confusion. They're not in clarification business. They want to create confusion so they can go in as a consultant and charge you really high price for it.
Mock is sort of like generic, stuff, but RSpec is the test.
Right.
Okay, so you're clear about what is expect and what is setting expectation is always should receive is how we set expectation. It's not expect, it's not actually setting expectation. Okay. So these are all side effects. Something going to the logger is a side effect, for instance, because we cannot really see with the naked eye. We had to go to the file system and open the logger and look at it, right? But we are not really using a real file system to do this. It's that mocking that we're mocking that logger. All we care about is like as long as somebody behaves like fakes as if they are the logger, this should be sent there. That's all I care about. Okay. And caching. One thing is like you have a mock here, and you create the SUT. You install the mock on it. Now you're setting the expectation on it. Should receive valid question mark with this once and return true. Okay, there is a lot of constraints on the API that you can use. You can have with certain arguments exactly once, twice, exactly 3 times. You can specify more constraints, but you should not specify more constraints unless it's really required. Because over specifying is one of the reasons why your tests become brittle. Because you're constraining the system so much, the implementation changes, even though the behavior remains the same, your test will break. Okay. In this case, I call the zip code twice. So the first time it will hit the layer, and the second time it's not going to hit. So the once will pass. If it gets hit again, it will fail. The caching is not working in that case. Okay. So in this case, I want to constrain and make sure it's caching properly. Should validate only once. Caching is one sense. Okay.
How can you specify that it should receive it once and then receive it again with like a different? Because I was messing with it to get with multiple should receives, but I couldn't figure out how to specify different arguments.
You want to chain different. You want to specify the sequence at which messages get. Okay, here is the thing. You brought in a very good point. Whenever you are constraining a certain thing should go in a certain sequence, it's more like a procedural thing. You are actually constraining the system and you are going towards where you're over-specifying things actually. What tomorrow you change the sequence, right? You want to specify as minimal as possible to capture the behavior. At the same time, you don't want to tie to the implementation of how you.
I can see a very valid case for wanting to do that where you have a default. Like if you're working with some web service or something, I'll try sending this user. Well, that fails. Well, let me try like a default read-only user. So I do have a valid case for wanting
Mhm.
to specify as like a backup.
I see.
But I'm not sure how to do that.
Okay, I don't know the syntax. Probably, that will be a very good question. Maybe RSpec mailing list. They may know how to use. See, there is a relishapp.com where Dave Kimley actually does a really good job of actually posting very good documentation on the existing RSpec. I would actually go through it first before I even post this on the mailing list. So interface discovery, we already saw this thing here. When you're marking, you're basically discovering what you want to actually mark. Thing I'm working on, something I need this, and return this, something complicated, you're discovering the API. That's what you did when you were actually working on Fibonacci, right? So the mark only types that you own. Don't mark things that you don't own because you cannot drive the design of something else. And mark only immediate neighbors. This is because you don't want to violate the law of Demeter principle. Like you cannot just keep on going A dot B dot C dot D dot E dot F dot. It's just because of a train wreck. From a design standpoint, just try to stay away from that as much as possible. If it's a well-designed system, you only mark immediate neighbors. You'll not chain calls for too many levels, right? The active relation is an exception because it's a relational thing, so that's okay to compose that way. But when you have your own object, just make sure you don't go too many levels, okay? And then mark only roles. I already said if it's roles, you can actually plug in. You can have the plug-in capability. You have like a student is a role. You can have a mark student, a real student, and then so this way it becomes pluggable behavior, okay? So in this case, you have different roles. These are the things I can mark. Don't mark a concrete person object, okay? These different roles I can mark, and I have written this code and I have control over this code, so I can drive the design of this code, so I can mark it, okay?
But
So
you can stub person. You can stub the person.
yes,
Not mark
you
the
can.
person.
No, don't mark the person.
Okay.
Don't mark concrete classes. Mark only roles, because it's also about pluggability, okay? So, and also values. There are two kinds of objects. One is like a value objects. Other one is like a identity object which has identity, right? Value objects are like currency, money. $10 in your pocket is the same value as $10 in my pocket. They don't have identity, right? Unless it's a fake $10 that you're having. So don't mark the value object. If it's a currency or a money object, just use the real object. Don't mark it, okay? So that completes the stubs and marks and the basics of testing. I'm just quickly going to run through this designing for testability and effective test automation. It's kind of like a very quick thing, okay? The layered architecture, if you have a well-designed thing, you'll have a layered architecture. So things you were like talking about, you have ports and adapters. If you read about this ports and adapter architecture, you have some Excel library. There's a technical domain, and you have an adapter layer that is going to actually translate all the terminology in this technical domain to your application domain. So you keep your application domain purely business, very pure domain model, okay? And you don't let any of this technical terminology to leak into your domain. You keep your domain model pure, and also it isolates from any of the changes that happens in the external library. Same thing here in the UI related stuff. You have adapter, and you have translating all the events going in and out. Okay. You can read more about the ports and adapters layers. I think Lester Cockburn or somebody who came up with it. And you have this application objects. You have a domain layer. And this is the question you had in the morning. You have adapter, third-party adapter. Okay, third-party API, like some web service, or what this external web service API is. You create a very thin layer, and you define a well-defined interface. These are the things that you own, actually. And your domain model only uses this. So by doing this, you isolate yourself from the changes that's happening on the third-party API at their own delivery schedule. It doesn't impact the release schedule of your domain. And you can have a learning test here. Like I said, this adapter layer will have its own test to make sure it can communicate with the third party and integrate well, so it runs properly in the production system. Okay, and since you have control over this, you can mark this particular thing because you own this. You don't own this, you stop this guy, and you actually have a real object going in your integration test running against the sandbox of the third-party API provider. Okay, and anything that calls back from the adapter layer back to your application object, you can mark it because you also own this when you're testing this setup cluster, for instance. Okay, this is a callback going in. Test double we already saw, so we want to see dependency injection. We already saw in the test code. See how we actually create the real object in the production system, but in the test environment, we create a test double, and we actually install the test double on the SUT. The client uses this test double in the SUT, so that this guy is actually using this guy when you do exercise. See this create, and then it's actually using, when you create this SUT, we'll actually make this guy use a test double. We already saw this. One thing I want to really mention is seams. If you find the seams, where do you actually, you just found dependency injection, you go and use it everywhere? No. You just want to find a pluggable points in your system, but how do you find a pluggable point? It's not like, it's kind of like something where you can plug in, but the behavior is more like, if you plug in something, the behavior should change, something more like this. If you change this and you plug it in, is the behavior changes, pluggable behavior. Okay, so basically mark object is misnamed. It's really a technique for identifying types in a system based on the roles that objects play. Okay, if you use the mark objects the right way. Okay. So I want to now briefly go over this thing of why, when you want to use stub versus when you want to use marks. So whenever you have a command, there is two types of messages you can send. I can ask, okay, what's your name? You say,
Mike.
Mike. So this is a query. I sent a person object a query. I got a response back. Okay. This I can stub. And if I say, okay, Igor, you can go and have lunch. He did not say anything to me. He just goes. His behavior changed. Okay, that's change of behavior. And if he really ordered lunch or not, I cannot really see. Ordering of lunch is part of what I really know. He really had his lunch. Then I need to use a mark in that case. Okay. So that is a command. I gave him a command. For you, I queried an object. That for this person, I sent a command. I don't know if that behavior was there or not. I have to make set an expectation on it. Okay. So query, I showed you what a query is. Name. My name is Matt, so I can stub it. You're basically reading state. Command. Here is another case of a command. I say person, I say, okay, save yourself. You're a user object, right? I send a save command to you, but you're extending from persistable, from an ORM layer, but you don't really know how to save yourself. You just delegate that call to the ORM layer. Okay? Just use one mark per test. Don't go crazy with using marks everywhere. If you get to a point where you're using too many stubs and marks in your test, I would actually stop and would actually see if I can just use real objects. Does it simplify your test? If it does, go ahead and use real objects, because I don't care if I'm a classic TDD guy or a PDD guy. My ultimate guideline for choosing one over the other is simplicity. Okay? Like I said in the beginning. You can stub change. Like I told you, mark only your immediate name, but you can violate it by using stub chain is available in RSpec. Be very careful. You can only do it only maybe you're using some third-party library. You have no other option than use it. Otherwise, this is a sign of a design smell. Okay? Control points we already saw where we are providing input and output. Observation points. Easy testing of system. If you followed all these things, you should allow you to easily test the thing. Okay. Effective test automation difficulty, and maintainable automated tests. Easiest to test is domain model, then the stateless service objects, then the stateful service objects. Hard to test code like transactions, multi-threading, GUI components, asynchronous messaging, those kind of things, right? There are ways to test them, but we won't be really covering them. It's like advanced topic. And legacy software, like anything that does not have any tests, could be OO, okay? And non-OO legacy software is even more difficult and challenging to test. And then roadmap to a highly maintainable automated tests. Exercise the happy path code, then all the alternate scenarios, pathological cases. Verify direct outputs. These are the you are asserting on messages. Asserting on messages is what setting expectations on marks is about. And verify alternative paths, right? All alternative scenarios. Verify indirect output behavior. I send a command. I want to verify, okay, he did send a lunch order or something. And then you focus on optimizing the test execution and maintainability. Okay, my else tests are very slow. I need to make it run faster. What are the techniques for making it faster? People are using, like I showed the mix-ins, where I showed where you can mix into a stub and you can run it outside of Rails now. And you can test your age identifier thing as part of the stub. As long as the stub has all the birth date and all the relevant fields, that is actually has some kind of coupling there, okay? If you want, I can give you the slides. So I would rather have you pay attention rather than on focusing on writing everything down, okay? You'll get the slides, don't worry. So that completes the entire thing. I just want to quickly run through this aspect quick tour, okay? Matchers, actual should equal. That's what you did. Okay. If you want to get going, you can get going actually. So equal, so you have in this case, you have equal expected, and then you have this equal, have question mark, equivalence, identity, be expected something. And then you have comparison, should be greater than, less than, should be within a certain given range of thing, like delta. If it's like a, 0.01 or something, And then regular expression, like Mike was saying. You can have regular expression and the string that you should match. Should be an instance of, should be kind of certain specific type of classes. And we should be true, should be false, should be nil, those kind of things. And they expect, the confusing expect. This is not really a mark. This is more like a post-condition check, okay? To raise some error, if you want to specify that specific error, you can specify. And if you're worried about the actual message, you can specify. I can specify both class as well as the method. And you can also say, throw a certain symbol and what that symbol is and what that value should be. Predicate matches should be happening. Those XXX will be like question mark that you need to implement whether it returns a true or false. Should have some arguments. And then ranges should cover 3, 1 to 10. Yes, it does have 3 in its covers. It's only for 1.9. And then you have some collection. Does it include something in the collection? If the collection is 1 to 10, does it include 3? Yes, right? 1 to 3 include 1? Yes. 1 and 2? Yes. This includes, this string includes is str? Yes, right? This is a hash, should include this? Yes. Should be empty, so you'll have empty question mark. Should not be empty, then again, empty question mark fails. And that's the end of the quick tour. So to conclude, have nothing in your houses that do not know to be useful or believe to be beautiful. Everything that's not useful or beautiful is clutter. And your software should be the same way. Either it's useful to the user or it's not. If it's not, delete them, throw it away. And if it's not beautiful, clean it up and make it beautiful. Okay? So we live in a real world, right? If you want to go back and do this thing, of course, the real world is messy. So out of clutter, find simplicity. From discard, find harmony. In the middle of difficulty lies opportunity. So it's not easy. It's not an easy job going to the real world trying to find simplicity. But I leave you with a message. Simplicity is what we are aiming for in TDD. the design, the documentation, being able to do this. It's an elusive thing. We cannot really define what it is, but you can recognize in some of the things I've showed you. But it's kind of like a journey. We are always striving for simplicity in our design, in our tests, in our code, everything. Right?
Well, thanks. If this was simple.
This is the first time I'm actually seeing people clapping for this. Because I refined my stuff so much, I've finally nailed the conclusion, what to
Can
say.
we get the